Hi everyone, I'm Stephen and welcome to Audio Nautica. And in this video I'm going to be looking at something that is neither audio or Nautica. As you can see, I've got these couple of Smith's alarm clocks, and I'm just figuring that if you've been following along in my channel, you're interested in the kinds of things that I'm interested in. So I'm interested in pretty much anything technical. Electronics is my main thing because that's what I worked in professionally, but I'm interested in all sorts of technical things, and I hope that you are too. So I've always liked clocks, I've always liked watches, I like vintage watches, I enjoy watching Vintage Watch Channel. I usually watch Marshall at Wristwatch Revival, and it's been really tempting. I've thought a few times about whether that's a path I want to go down, but I thought about the cost of the tools required and it would just be too much. But these won't require those level of tools, and hopefully won't be as complicated. So I picked these up on eBay. This one doesn't look especially pretty, but I got it because it has Commonwealth of Australia on the face. So it's got an interesting story, so it's a little bit interesting. And this was advertised as not working, but as far as I can tell, it seems to work perfectly fine, so I can't see anything wrong with this one. This one here I picked up because I really like the look of it. I love this face, I love this red, I love the style of the numerals, I love this red plunger top, whatever you call this thing. So yeah, that's why I picked this one up. The perspex is a little bit damaged, but it'll be okay. So this one here is running too fast. So it gains about 15 minutes in 12 hours or so. And the other thing that you can notice about this clock is that it's really loud. So I did actually try sleeping with this one, which is the one that works properly, using it as an alarm clock, but the ticking was so loud. I guess I'd get used to it over time, but I just want to investigate too whether it is actually possible to make these things run a little bit quieter. It might be impossible, we'll see. But certainly this one here does have a fault, it's running too fast. There is an adjustment at the back. When we pull it apart, you'll see how it works. But this adjustment here, if I wind it, you can probably hear it's now running faster. So that's the increased speed adjustment, and then if I bring this back down here, you can hear it slowing down. So this works by adjusting the length effectively of the balance spring, which is what determines the speed that the clock runs. So anyway, without any further ado, let's start pulling this thing apart and see what we can find. Okay guys, so first of all I do need to say I have no idea what I'm doing. This is the first time I've ever opened up something like this. If I use any technical terms, I may be using them wrong, but everything I know I've learned by watching Marshall's channel at Wristwatch Revival. There's also a guy who runs a channel dedicated just to alarm clocks, and he does do a teardown of one of these Smith's clocks on his channel. So I'll be referring to that every now and then if I get stuck, and that's Pin Palette 20. Pin Palette 20 is his channel, so credit to him. So basically the first things that I need to do is take these parts off the back. So this is the winder for the alarm, and this is the winder for the clock itself. Then here, this is the adjustment for the hands, and it just pushes on like so. So here, that's just a straight shaft, and this is the adjustment for the alarm time, and that also screws off. by screwing it the reverse way. So this shaft is threaded, this shaft is not threaded. So also you can see, it's a little bit clearer to see now, stamped on the back is a number. So it's just a bit of black there, so it makes it a bit hard to see, but that I believe is 60. So 1960. And this other one here, that one's much clearer to see. I'm not sure if you can see it, but it's, see if I can pick it up, 1965. Possibly just need to see it in the light there. 1965 is this one. So yeah, so 1960 for this one. So we have all of those parts off. Then we have these four screw nuts will be holding the movement in. So we just remove those. I'll just leave two of them in for now so the whole thing doesn't come apart. So we need to get this bezel off. We can see that it goes down in behind the case. Looking at the foot, you can see there's this little cutout, and see I can see the bezel there. So I'm guessing that what I can do is just pop in a screwdriver like so. Yeah, and just give that a little bit of a persuade. And then I've got a little tool here. I don't want to scratch it, obviously. I think that's got it. Yep, that's got it. So, yeah, we can see this beautiful bezel. Tiny little bit of rust around the inside, but you know, looks pretty good as it is. Clean up even better. And here we have the face. So it does have kind of like, I mean, it's perspex. It does have these kind of cracks there and there, but they're not too noticeable. Then there's a few sort of like general wear cracks. I might be able to polish some of those out. We shall see. So yeah, perspex. Perspex front. Let's pop those out of the way. So I believe that I should just be able to pull the hour hand off. Because Pin Palette 20 said on his channel that Smith's hands are not on tight. Well, this one does seem to be tight. Whether that's because of corrosion or what have you, I don't know. Now, I don't actually have any, I don't have any hand pullers, so I might just have to go having a look to see what I've got to get this off that will not damage the face or the hands. Okay guys, so basically I'm just using a little flat blade screwdriver and I'm just putting that in there and just a little persuade and off the hand comes. Being very careful not to damage the face especially. So the face, you can see, has got some marks around the edge. This will be where the bezel has been sitting, and just the movement of the bezel with respect to the face has caused these marks, but they won't really be noticeable when the face is in place. So let's just see if we can pull this guy off. Yes, that was pretty tight, but that did come off just with the fingernails. So that's that hand. Now, according to Pin Pallet's video, oops, I do not need to pull the hour hand off. So I'll just take the last of these off so I can get the movement out. There we go. Yeah, so there's the inside of the case, a little bit of rust down the bottom, but not too bad. So according to Mr. Pin Pallet, when I take the face off, now I might just have to, there's these little lugs, 1, 2, 3, there's one down the bottom as well. Yeah, you can see that the hour hand comes out as well. And if I just sort of might be able to persuade this without having to move these lugs. This one's folded over a fair bit. Yeah, it is folded over. I don't want to damage the face by doing this, so I'll just need to put something protective down and just give this a little bit of a bend, I think. Okay, so I just bent this lug back a little bit. I just put some plastic down on the face just to protect the face and just pushed it with the screwdriver, and so that has freed up, and now the hour hand just comes off with its cog. So yep, that's what happened in Pin Pallet's video, so that is now free. So there we have our movement. I'm working on the assumption that these kinds of things have probably never ever been serviced in their life, because they're just not they're not expensive items like a wristwatch, and they're not, you know, a show or a dress kind of item. You know, you don't take your you don't take your alarm clock out with you. So, you know, for most people, this would have just sat by their bedside as a functional kind of item until they no longer had a use for it, and then it might have been thrown in a drawer, which is presumably how these kinds of ones have ended up on eBay. So yeah, so basically also these don't have any sort of like sealing in the same way that a wristwatch would as well. So that means that they are much more prone to getting dirt and dust inside of them. So you can see probably just around this bearing here, which is for one of these springs, there's a fair bit of grease just around here, grease and dirt. But it doesn't look too bad actually, not as bad as I was expecting it to be in terms of dirt. So, a bit of gunk on the bell. But this should be given a clean, it should be given a strip down and a clean. But my main purpose is firstly just to see if I can determine why this one is running too fast, because I don't want to go to the effort of stripping it down to have it still faulty. So there we go. Okay guys, so just a little bit of familiarisation. I've got this sitting back in the case. So this plunger is just located in the top of the case. This is what disables what you use to stop the alarm when it goes off in the morning. So basically when you turn the bell spring, when you put power into the bell spring, this lever, this arm, which you'll see in a tick, pops up, which pops this up. So it's very clever. It's kind of like my electronics brain thinking now. It's basically a mechanical and. So as you move around the So the alarm mechanism is now armed. This has popped up. When the time on this matches the current time, the bell rings. And at some point I'll work out how this works, but I think what I noticed, I'm not sure whether this is part of the mechanism or not, but it's probably a bit hard for you to see where you are, but this wheel, it moved out. When this wheel was in the same time, it moved out, but it might need to be armed as well. So let's put some power back into the spring. Aha. So that popped out. That popped out when it was armed. So this popping in and out is, and there's a big spring on the back of this. So a spring bar, so that will be part of it. But anyway, enough of that. So the other part that I'm especially interested in for right now is down here. So the power for the watch to run comes from this spring. So if this was a wristwatch, you'd call this the main spring. And in a wristwatch, this would be all in its own little housing, which you'd call the barrel. There is no barrel, it's all open. So you can see one end of the mainspring is actually wrapped around this post, and the same thing on the other spring, which is for the ringer. It's wrapped around this post, and the other end will presumably be on this spindle. So this basically just winds and unwinds just in free air, and yeah, it doesn't feel like it's got a lot of grease on it, but that's all right. So this is where the power comes from for the watch to run. But then the principle of how a watch runs is that the release of that power is regulated. So yes, you have to control how that power is regulated in a known and predictable manner, so that the hands turn at a known rate, which is how it tells the time. And that's done with this down here. This is called the balance. And as you can probably see, if I just stop it, bring it in a bit closer, bring the light in, it has a spring. You can see there's the spring. So that's called the balance spring. And basically there is a spindle. You can see there's a spindle. And we have this wheel here, which gives it mass. And also on the wheel there's a little pin. So we'll just bring the little pin around to the front. I'm not sure if you can see the pin, but well, there it is. You should be able to see the pin there. That pin is what is moving this arm back and forth. So I think in a wristwatch you would call this arm the pallet fork. So essentially what is happening is that this wheel is mechanically oscillating, and that oscillation is controlled by this spring, the balance spring. So effectively the length of the balance spring determines the rate of oscillation. So basically if I do this, you can noticeably hear that the movement has sped up. So because there's an arm here and there's a slot in the arm. So I'll just bring this in more closely so that you can see there's a slot in the arm, and the balance spring is going through that slot. So effectively, by moving this, it's changing the length of so effectively the start of the balance spring is now here. Okay, so we've made the balance spring shorter. If we move this arm back here, Notice how the whole thing is, well, that's really cool actually. Notice how the whole thing's moving in and out like this. So now the point where that motion starts is back here. Okay, where this whole thing moves in and out. And you can, I'm sure you can hear that the movement is noticeably slowed down. So if we bring it around to here again, notice how this part here is no longer moving in and out. The inside ones are, but because we move this arm, this little section here of spring is out of the equation, so we've sped up the movement. Okay, so the problem that I have got is that this movement is running too fast. So what that means is that in this position, the balance spring is still too short. So yeah, so you're not going to be able to see on the camera, guys, but well, you can see part of it. Let me just get a poking device. See this arrangement here. This is what secures the end of the balance spring. So basically there's a piece of metal here, which I understand is basically a wedge. Now this is the thin end of the wedge, so to speak, and the thick end of the wedge is down there. I'll just come in closer so you guys can see better. So the thin end of the wedge is here, thick end of the wedge is there, and there's a slot here. So the end of the balance spring goes through this slot. Now, I can tell, I don't think it's, well, you might be able to see if you're really lucky. Let's see. You've got to sort of like look through there. You can see that there's about 5 millimeters of balance spring that is poking through that slot. So what I'm really hoping is that this has been disassembled and reassembled at some point, and that whoever disassembled or reassembled this has not reinstalled the balance spring correctly, resulting in it being too short. So basically, if this wedge is taken out and reinstalled, then hopefully the clock should run at the correct speed. Okay guys, I'm back and I just want to sum up my findings on this Smith's alarm clock movement. I'm not going to be tearing it down in this video. I'll do a full strip down and rebuild in a subsequent video, but this was just a familiarization and preparation prior to doing that. So one of the important things that I needed to work out was how to let the mainspring down. So as you can see, this spring, this is the mainspring, it's all uncoiled, so there's no energy in it. And it is kind of tricky to show you because the point that we're looking at is sort of in there. And just with the exposure, I'm not sure that I'm going to be able to get enough light in there. I can see it with my eyes, but the exposure on the camera is a bit different. But you'll see that there's like an end of a round spring. I think that's part of the mainspring mechanism, and it engages with a cog. So that effectively is the click. So as you wind the spring, the cogs rotate obviously, and that piece of metal goes up over the cog and then latches with the next one, which prevents the spring from unwinding. Basically stops the spring from unwinding back the way that it came. So basically, the way that I let the mainspring down is I've got the winder on the back of it. So with my fingers on the winder, I got a screwdriver in there and was just able to prise that piece of metal back so as to be able to then let down the mainspring. So that's the that's the general idea as to how that works. So a couple of other things that I was looking at, I mentioned some problems with this balance wheel, potential problems. So this clock does run too fast. It gains about 15 minutes in 12 hours, so that's, that really is way too fast. And I mentioned that I noticed that this hairspring looks like it might have been fed too far through this keyway, which would make the hairspring too short, which would make the clock run too fast. The hairspring does look like it has potentially been mangled a little bit. So I was able to refit this. Now I haven't checked it for its timekeeping accuracy because this will all have to come apart anyway in terms of a strip down. All these bearings and so on will need to be cleaned, have all the dirt taken out of them. This is a fairly clean clock, I think, relatively speaking, but all of these bearings will need to be disassembled and cleaned. So there's no point going to a huge amount of effort on the balance spring to get that sorted out right now. But I just fiddled around with it so that I believe that when I take it apart, I will be able to get that sorted. But yeah, I think this balance spring, there are a couple of places where it looks like it might have had a kink in it, and that wouldn't help either. So fingers crossed. But look, worst case scenario, if I strip it down, put it all back together, and it still gains too much time, then at least it's been a good learning exercise, because I've got this other clock here which will need to be done as well. And the thing I really like about this clock is the face. So if I decided I wanted to keep it, I could get another movement from somewhere. But the other interesting thing to look at, so just on the balance, sorry, I was having trouble with this wedge. Very, very simple, these things. This wedge literally wedges the end of the balance spring in place. And when I took the wedge out, I couldn't get it to re-wedge again. So it's kind of really, really weird in that it wasn't in this way around, where you can see the thin end is at the top and the thick end is down the bottom. So that made me think that this is the thin edge of the wedge, but I'm not so sure that that's the case, because I checked in Pin Palette 20's video, and the wedge is definitely fitted from the top. So when I took this out, I took it out down the bottom, and then after that, I couldn't get it to wedge again. So it's just made of very, very soft brass. So maybe the thin end was the thick end. I'm not so sure. But anyway, what I did is, as this is made of brass, I was just able to put some solder on one end. So I put some solder on this end that makes this end thicker, and then that allowed me to make it function as a wedge. I didn't worry about it too much because this is all going to have to come out again. But I think I'll be able to get that to work as it should. And I might swing it around so that the thick end is the thick end, even though that's not the way it was when I took it apart. But you can probably see that the spring is just slightly to the side of the wedge, and I don't think that's quite right. And it's not as sturdy as it should be, so that will need to be resolved. And I'm pretty sure I can do that. Now, the other thing that I wanted to look at was, why does this run so noisily? What makes this clock so loud? And my initial guess was that it might have been the balance wheel against the pallet fork. So you can see, if I just swing this around here, get a pointer, you can see that the balance wheel has got this shiny pin sticking up here. And what this pin does is, as the balance wheel rotates, you can see that it moves the pallet fork back and forth. Okay. But that's quiet. That's not making any noise at all. So it isn't that. So then, if we have a look at the action of the pallet fork, so if I, again, put some power into the balance, because there's no power in this clock at all, it's totally wound down. So, but this will just run for a little bit, the balance spring will just run for a little bit under the power that I put into it. So you can see that the pallet fork goes back and forth and it engages. So there are two pins. There's a pin here, See this upright silver pin? Then there's another pin here. Now these pins engage with the escape wheel. Now it's covered in this white lithium grease at the moment. The reason I did that was just to see whether that would affect the sound, and no, it didn't. But anyway, I have been able to verify what it is that actually makes the sound, and basically I can prove that if I put some power back into the clock. Let's put a good amount of power back into it. I'll just turn the other microphone on and bring it near the clock so you can hear a bit better. Okay, there we go. So you can hear now that classical tick tock, and the tick, basically what it is it's the escape wheel under power slamming into those pins. So there's two stages of motion corresponding to the two positions of the pallet fork. So the tick sound is the sound that you hear when the escape wheel slams into the pin that is closest to us, and the tock sound is the sound that you hear when the escape wheel slams into the pin at the back. And the reason it makes so much noise is because of the power. There's all of the power of the spring is effectively behind that cog, and the cog wants to completely unwind, but it can't, because every time that it tries to unwind, it slams into one of those pins. So the pin is controlling how far the wheel can move on each oscillation, and that's what determines the timing of the clock. So it's a fundamental principle of how a watch works. And it's the sound, the volume of the sound is determined by basically I guess the power that's involved when the wheel slams into those pins. So you can see that this oscillates at a fairly slow rate. A wristwatch tends to oscillate at a much faster rate. You might have effectively several ticks per second. So basically, the more ticks that you have per second, the less amount of power is released in each tick, and the less amount of power that you release, then the less noise that you're going to hear in the mechanism, as effectively the escape wheel slams into these pins on the pallet fork. So that's the reason, that's where the noise comes from in this clock. And any other clock or watch, the principle is basically the same. So I kind of fiddled around with ways that I might be able to make this run quieter. I did experiment with just putting a couple of tubes of heat shrink over those pins, and it did run for a little while with the heat shrink over one of the pins. So basically I got tock, tock, tock instead of tick tock, tick tock. But when I fitted the heat shrink and shrunk it down, the geometry was just such that it didn't engage properly with the wheel, and it didn't run. So, no surprises there, but I thought it was worth a go, nothing to lose. And then I just tried with this white grease just to see whether the grease on it might make it run quieter. I think it has actually made it run a little bit quieter, but it isn't really a solution. So I think it's going to be something that I'm going to have to live with. Potentially if one could get something really, really small, like maybe some Teflon tape or something around those pins, it might quieten it down a little bit, but I don't have anything like that, and I suspect it probably wouldn't be that effective anyway. So anyway, that was an interesting exercise just to learn about what makes the classical noise in these clocks. So that's about all there is to show at this stage. I'll wrap things up here on this video. This one has been a little bit different, I know. I hope you enjoyed it. If you did, please give me a thumbs up and please subscribe to my channel. And I look forward to seeing you on the next one. And as I mentioned, hopefully I will be doing a tear down and rebuild of this clock at some point in the future, so keep a lookout for that. Bye for now.